Metric prefixes. So this map of the world here is showing USA, Liberia, and Myanmar, highlighting those countries. These are the only three countries that still use the imperial system. Most of the world is in fact on metric. The metric system is the preferred measurement system in the sciences and pretty much everywhere in the world. It consists of several base units, which are modified by prefixes that indicate magnitude. So meter measures length, abbreviated by a lowercase m. Gram, abbreviated with a lowercase g, measures mass. We use Kelvin as our base unit with a capital K for temperature. You might also see Celsius as well. Seconds with a lowercase s is for time. And these ones might not be so familiar to you, but a mole, abbreviated MOL, is amount of particles. So we use it to count atoms or molecules or ions. Candela, CD, is for intensity of light, and ampere A is for electric current. So these base units can be used to measure any of these quantities, and I can use a prefix to modify the amount. So for example, I can measure distance in meters. If I want to measure a small distance, I could measure it in centimeters. If I wanted to measure a large distance, I could measure it in kilometers or kilometers. But both are still meters. So each base unit in the metric system can be modified by any of the prefixes that you see here. So for example, a megameter, capital M, lowercase m, is 1,000,000 times larger than a meter. So all of these multipliers can be added in front of whatever base unit. So for each of the following, we want to write the correct abbreviation. So the capitalization here matters. For example, a lowercase m and an uppercase m mean very different things here. So go ahead and take a couple of minutes to try this question. You can pause the video and return here when you're ready to check your work. So a millimeter, lowercase m, kilogram, centisecond, a millimole. So there isn't much of an abbreviation for mole, it's just MOL, but we want a lowercase m there. If I put an uppercase m, that would mean megamole, which is very different from millimole. Nanometer, you've heard this before, that's NM, and Kelvin is just a regular K. So we want to make sure we're using the correct capitalization here. Lowercase k means kilo, uppercase k means Kelvin, a way to measure temperature. So for each of the following, we want to determine a conversion factor. So this is a ratio that lets us convert between different units here. So first we have how many meters are in a kilometer. So kilo, the prefix, means 1,000 times bigger. So there's two ways that I could write this. I could say that 1,000 meter equals 1 kilometer, or I could say 1 meter equals 1,000 kilometers. Now we need to think about which one of those makes sense. So kilo means 1,000 times bigger. So a kilometer is 1,000 times bigger than a meter. So the correct way to state this conversion factor would be this guy. Go ahead and pause the video and take a couple of minutes to answer the next couple of questions. And when you're done, return here to check your work. So whenever we write our next conversion factor, we have milliliter. So milli means 1,000 times smaller. So what that means is that 1 milliliter is 1,000 times smaller than a liter. So which of these shows that correct relationship? That's going to be this one. Milliliters are small, so if you have a liter, you have a lot of milliliters. Next is grams in kilogram. Notice that the conversion factor is very similar to the first one. We're still trying to go from base unit to kilo, so we still need that conversion factor. It's just that our units now are grams. Now the next question is sort of asking this backwards. How many kilograms are in a gram? So we know that a gram is going to be 1,000 times smaller than a kilogram. So if I have 1 kilogram, I must have 1/1000th. 1 gram must be 1/1000th of a kilogram. Okay, you're going to go ahead and pause here and go to this URL, and you're going to watch this video and listen for the answers to these questions. And when you're ready, return here to check your work. So the U.S. customary measures system with feet, ounces, miles, this is based on a human scale. So a foot is about the size of a foot, an inch is the width of your thumb. So in early American history, this was actually much more consistent than the measuring systems used in other countries at the time. So there are plenty of places where there was no uniform measurement system. So that was really useful in early American history, especially when it comes to things like trade with other countries and finances. So do you agree or disagree the U.S. is secretly already metric? Explain. So I say agree, because we are metric every place where it matters, every place where it counts. So doctors, engineers, nutritionists, food service, all that stuff is done in metric. So explain why being able to move a decimal point is useful. It allows us to easily measure anything of any size with one set of units. So I can use centimeters to measure something small or kilometers to measure something big, but they're both still meters. In the U.S. customary system, if I want to measure something small, I might use inches. If I want to measure something big, I might use miles. But an inch and a mile aren't related to each other in any direct way. The way that a centimeter is related to a meter, that's always going to be 100.